So on here as well, guys, this talks to you about the aspect of excellence and improving your model. And if you click on the link, this is just in the PowerPoint. If you click on the link, that will take you to a document with lots of different options for improving your model. You only need to do one of these. It might feel appropriate to do two, but you should not be doing more than that, because what you need to do is do one really well. Before you do an improvement, you have to tell me how you might improve your model because of what you see with your graph or because of what your research tells you before you do it. You can't just go, wham, here's a new graph. You've got to have a reason to do it. So here's an example of nonlinear. You would tell me, typically nonlinear is where there's under predictions or over predictions. Typically at the ends, but also you might find in the middle here. So the line is underneath all these points. So it's under predicting there. That makes us think a curve might be more appropriate. Once you've fitted the curve, you need to discuss these things. Visually, where is it a better fit? Be specific. Where are the points closer than they were before? Repeat one of your predictions. Tell me, is it more reliable? Is the model a better fit there? How much does it change the prediction? Is this model an improvement? And when should you not? So for curves, like parabolas, it would go up and then at some point it would start going down. So you should explain that to me if that's going to be an issue. Depends on the context. Piecewise, we don't really tend to do this, but if it made sense that if there was a sudden change after a certain value, you might go back into the spreadsheet and delete all the early values and just do a model for the end. And you could then do a model for the early values and a different model for the end values. Like that. The downside of this is if you have a model that's typically got like less than 15 or 20 points, it's not really very reliable anyway because it's not using a lot of data to form that model. I would generally avoid piecewise. A different explanatory variable. Now, this can be really useful. You might have done, I want to use temperature to be able to predict growth, but maybe something else would be a better predictor of growth. So you could investigate other variables, looking for a stronger relationship, but not necessarily linear. This is the separate groupings. So this is on NZGraphy. You can color code and then split your graphs. Now, when you do this, you need to either color code and discuss it, or with what your research tells you, why might it make sense to treat the two groups differently? And then you can do your graphs. You can't just plonk the graphs in. Once you've done it though, visually, where is it a better fit? How has the new model changed the gradient or the y-intercept? How has it changed your predictions? Are they now more reliable or less reliable? Is this an improvement? Is there any way you would not use this model? So here's a little example. You can remove unusual values if they are really unusual. However, beware, massive beware. You can't just remove a point because it doesn't look nice. But what you can do is you can remove the point, redo predictions, redo your graphs, and actually just discuss the effect that point has. So you might have one observation, one point that's much bigger than everything else, and it might actually almost create a trend that otherwise wouldn't be there. Or maybe it makes your trend stronger or weaker. So you can have a play around with that, but you can't just remove them. You have to say all you are doing is investigating the effect that it has.